Hello everyone, I am Vikas. In this talk, we present CoNMix for source-free single and multi-target domain adaptation. This is joint work with Rohit, Himanshu and my research advisor, Professor Anirban. What is domain safety in unsupervised domain adaptation? In this case, training and test dataset come from two different distributions. Therefore, model performance drops while testing. In a standard UDA, both the level source dataset and unlevel target dataset can be accessed during adaptation. Therefore, both of the dataset can be present on the same server. It may not be suitable for applications which require data privacy. This issue is addressed in source-free domain adaptation, where we perform adaptation without accessing the source dataset. All we need is source-trained network for doing source-free domain adaptation. Source-free domain adaptation is critical in many applications, such as preserving medical record. Dataset is much larger in size compared to the network parameter. Therefore, transferring network parameter is easier. Also, many regulatory laws does not allow data to be moved from base location. Source-free domain adaptation is suitable for all such scenarios. In multi-target domain adaptation, we have one level source domain and multiple unlevel target domain. For example, we may have object detection model trained on sunny condition and we want to adapt it to night, rainy, snowy conditions simultaneously. Single target domain adaptation is a special case of multi-target domain adaptation. We propose a three-stage algorithm for solving source-free single and multi-target domain adaptation. In stage 1, we train a classifier using leveled source dataset and cross-entropy loss. In stage 2, we initialize teacher network using pre-trained source weights. We take a strong and weak level preserving augmentation of each target sample. Finally, we train the teacher network using the nuclear norm maximization, pseudo-level based cross-entropy loss, and consistency loss between weak and strong augmentation. We train different teacher network for each target domain. Finally, in stage 3, we train a student network from scratch. We take convex combination of two different samples and their respective pseudo levels. We train the student network using the mix-up knowledge distillation loss. We have three loss components for training each teacher network in source-free single target domain adaptation. First, we use nuclear norm maximization on batch-wise softmax output, which we call it class response matrix. For batch size B and number of classes K, class response matrix will be of size B cross K. We also use pseudo-level based cross-entropy loss and consistency loss between different augmentations. These are the complete expression for pseudo-level based cross-entropy loss and consistency loss. In source-free MTDA, we use mix-up knowledge distillation loss using convex combination of two different samples and their respective pseudo-levels. In our analysis, we observed that soft KD works better for generalization. These are the result of source-free single target domain adaptation on Office 31 dataset. We perform experiment using both ResNet as well as the Vision Transformer backbone. CoNMix with Vision Transformer backbone works best among source-free methods. CoNMix works better for both ResNet as well as Vision Transformer for Office Home dataset. Interestingly, our source-free method performs better than some of the recent UDA methods which assume access of the source dataset during adaptation. Information maximization is widely used in source-free paradigm. Therefore, we perform ablation to establish the effectiveness of nuclear norm compared to information maximization. We can observe that model performance is better for nuclear norm loss. Pseudo-level refinement helps to improve the overall performance even further. We study source-free multi-target domain adaptation for the first time. Therefore, these results will be a good baseline for future work in this direction. We observe significant performance gain for CoNMix on large-scale domain and dataset. The model performance improves even further when we use Vision Transformer as a student network backbone. In this TSNE plot for source-free multi-target domain adaptation, we try to see how well classes from different domains are clustered, and we observe that samples from different domains but same classes are clustered together. Key takeaway from this work is that our proposed novel framework can address both source-free single and multi-target domain adaptation. CoNMix source-free performance is better in some cases where the competitive state-of-the-art method accesses the source data during adaptation. CoNMix leverages self-training using target pseudo-level and nuclear norm maximization along with other components. We also saw that using modern Vision Transformer, we can obtain better feature representation. Refer to our project page for more details. Thank you.